think we'll get started. My name is Pedram Naveed, and I'm the head of data engineering and DevRel here at Dagster. Today we have Colton, who will be talking to us about Dagster Deep Dives, configurations and resources. This is our second one in the series. So just so you know, we'll be sharing a screen, and then after that, we'll have some time for questions at the very end. I'm going to be in the chat as well, so if you have any questions, feel free to join the chat and message us there. The session will be recorded. We'll be sharing out the recording as well at the very end. So, yeah, Colton, take it away.
Awesome. Thanks so much, Pedram. As Pedram said, my name is Colton Padden. I'm a developer advocate here at Dagster Labs, and today we're going to be talking about configurations and resources. So first things first, configurations and resources are really the fundamental building block of data pipelines in Dagster, and they're what allow you to have reusable and flexible code. Today, we're going to demonstrate three things. The first one will be writing pipelines locally and then emulating staging or production so that you know you can have the confidence to deploy to production after you do your local development. We're going to talk about standardizing your code base in a reusable way, leveraging resources so that you can use them across assets, but only define them one time. And then we're going to talk about leveraging the power of the Launchpad for ad hoc job analysis. So what's a resource? Well, at the end of the day, a resource is just Python code, so it can be anything, but it's a standardized way of defining a connection to an external service. This can be something like cloud storage, like an S3 bucket, a database like Snowflake or Postgres, or even BI tools. These resources are what you leverage in your assets and ops to connect to different systems. Dagster actually has a lot of resources out of the box through its integrations. If you go to dagster.io/integrations, you can see a few of them. We have integrations for Airflow, Datadog, dbt, DuckDB. A really exciting one that Pedram's been working on is the embedded ELT, which integrates with Sling, and that really opens up even more possibilities for your pipelines. If there's an integration that's missing, Dagster is open source, so you're welcome to contribute it, or you could join our Slack and let us know and we can collaborate on that. All right, so what's a configuration? Well, as the name suggests, it's just a way to configure something. It's a way to specify parameters for your assets, ops, and runs. Configurations are used all over the place in Dagster, and they ultimately get propagated up to the UI and are visible in the Launchpad. We'll demonstrate using the Launchpad later on, but it ultimately is a YAML render of the configuration, and then you can tweak parameters there. It's really powerful. All right, so what are we going to build? Here's a high-level overview of how the components fit together. I'm actually going to show this same slide later on in the presentation to review it, but you can see we're defining two assets. One is a base table, so we're going to be calling out to data.gov to get some New York pollution data. We're going to write a CSV reader to load that file, and then we're going to populate a DuckDB table. In this demo, we're using DuckDB, but it very well could be Postgres or Snowflake. Then we're going to create another asset on top of that for a report. And this will be the top pollutants from that base table. We're going to write a job that leverages these assets to materialize them, and then schedule this job to run in two different ways with differing run configs. You can see with the red diamond shape that these configurations are used all over the place. So our resources can be configured, the asset itself can be configured, and even the job can be configured with a run config. All the code for this demo is available in the DevRel project demos repo, and there's a bit.ly link in the top right there if you want to check it out. All right, let's dive into the code. I'm also going to be showing the code for the demo portion, but I wanted to kind of walk through it first. So here's how we use and define resources. We're going to use the DuckDB resource that's provided by the Dagster DuckDB integration. So that one's already written for us. So we're defining an instance there, and we're passing in this DuckDB database environment variable to the database parameter. You might be wondering why we're using this Dagster envvar class instead of the OS package. And that's because when ultimately this gets shown in the UI, the envvar class will censor secrets, so you don't show passwords. Also, this envvar it gets loaded at runtime, whereas if you use the OS package, I believe it gets loaded when your code location is loaded into Dagster. Cool. So that's our DuckDB resource. Below that, we're defining our own custom CSV resource. And this is a super simple example, but we're inheriting from configurable resource. We're defining an attribute on it called location. This will be the path to our CSV file. And then we're defining a method called load dataset. And this just takes that CSV path and loads it into a pandas data frame. This is super simple, but you can imagine how you could wrap really anything in a resource, whether it be calling out to an API or some system. And then you're defining this in one location, and then you can continue to iterate on it and improve it over time. And then this resource will be, the changes will propagate throughout your code base. You could imagine adding metadata that ultimately gets sent to the asset and then shown in the UI too. Cool, so those are the resources. I also wanted to show you what the DuckDB resource looked like. So this is actually the code from the main Dagster repo. And it looks just like our CSV resource. It takes in two parameters, database and connection config, and it defines one method, get connection, where it yields a connection. So super simple stuff. One thing I didn't mention is that we're using the Pydantic field class for these attributes, and this is super powerful. So configurable resources use Pydantic under the hood, and that allows you to have self-documenting classes. So you can see how we have descriptions there. And then it also provides validation on the types of these attributes. So you can be confident that your engineers are using the configurations how you would expect them to. Awesome. So let's define an asset. So here's our New York air quality asset. This is our base table. We're defining a method and using the asset decorator, and we're passing in 3 parameters to this function. We have our 2 resources, the DuckDB resource and the CSV resource, and then a configuration. In the body of the function, you can see how we're using those resources. We just called load dataset to get our data frame. We do some normalization on the columns, and then we get a connection to DuckDB, and we populate a table using that data frame. It might seem like magic how we're getting these resources to our asset, but that actually happens in our global definitions. So on the right, you can see where we register our assets, jobs, and schedules. We're also registering our resources. So we define our database resource and our air quality CSV resource there. And that's how the asset has those resources available to it. Now here's our other asset. This one takes in our custom report configuration. And you can see we're defining a couple of attributes there, just a limit, a measure type. In this case, we'll be looking at nitrogen dioxide levels from our air quality data set, and then a destination table. You can see in the body of the function, we are using that configuration in our SQL query to limit the amount of records returned, and then also write to a different location, depending on what's specified in that report config. I do want to point out that the SQL here is vulnerable to SQL injection if the configuration were tampered with. But for demonstration purposes, I didn't want to go into the depth of using like SQL identifiers or parameterized queries and stuff like that. But this is not production ready in particular. On the right-hand side, you can see how this configuration is then rendered in the Launchpad, the YAML that I was referring to earlier. So you would see this if you went to materialize this air quality report asset. And you can see we have our asset configuration on lines 4 through 6, and it defaults to what we defined in our report config on the left. You can also see the configurations for the resources there, the air quality CSV, which has a location to some environment variable. And same thing with the database. It points to the DuckDB database in some environment variable. Nice. And finally, let's look at how we would schedule those jobs with different configurations. So we have an hourly job and we have a daily job. The hourly job is going to be just using the defaults of our configuration. I could actually remove this line entirely and it would use the defaults, but I wanted to explicitly show it just for demonstration purposes. And then on the bottom, you can see how we override that configuration to increase the limits and change the destination table. This is a super powerful way of doing things because you can write your job one time, and you could imagine having multiple stakeholders who need a similar report just with different parameters or run at different frequencies. You could define that job once and then define run configurations for each stakeholder. Or for example, in this case, if it's like a really big job to run daily and like a smaller job that you would want to run hourly, you have a lot of flexibility here in how you run things. Cool. So I wanted to show this one more time. Now that we've looked at the code a little bit, maybe it'll click a little bit more. But again, we're defining two assets that leverage resources that are configured. We've defined a job that can take in a run config, and we're scheduling it in two different ways. Awesome. Cool. So now let's actually look at the code and run it locally. Again, this code is available at DevRel project demos. And I'm going to go ahead and bring my terminal over and increase the font size. Ooh, we actually go like this. So here we have that DevRel project demos repo checked out. And inside of that, we have this project blitz folder. You can see we have a couple of demos in this folder now. We had last week's demo on automation and this one on resources and configurations. We actually have a make file in this code base where we can just call it make run and choose the project that we want to run. In this case, we'll select 2 for resources and configurations. And then this should become available on localhost port 3000. Sweet. I'm gonna go ahead and just split this terminal and change into the resources and configurations directory. Nice. All right. So first things first, let's open this env file in the, oh, 1 second, I have to go. That's actually back to. We have this environment variable file in our project. And you can see right now, we're just saying we want to run environment equals local and use this local duckdb. We also have like an example of .env staging, and you can see how we might want to point to a different location. You could imagine that you have your Snowflake connection details here, so that when you're running locally, it hits a local instance of Snowflake. And then when you deploy it to a QA environment, you use the QA database with a different schema, and then finally production. Let's open up our resources.py file. And here you can see how we're leveraging those environment variables. So again, we have our duckdb resource that takes in the duckdb database variable. And then we have our custom CSV resource. And I actually changed the code a little bit from what you saw in the slide deck here. We're actually using this environment variable and saying if it's local, use this sample file, the sample CSV. If we're in staging, production, or doing a branch deployment, let's actually look at the real data set that's available on the City of New York's website. And then you can see when we instantiate our CSV resource, we're using that environment-specific location. Cool. So let's go over in the UI and let's actually materialize this base table. I'm going to go over here and click Open Launchpad just so that we can see the configuration. But you can see that our location here shows that we're using the SAM file. So if I go ahead and materialize that, we should see that it's not the full data set that's being loaded. If you recall, if I look at the assets file and we actually look at the code for this base table, we're actually returning some metadata. So after we populate the table, we're then querying it to get some information about it, like the column count and the estimated size. And you can see on this right-hand side, when we look at that metadata being returned in the event log, that the estimated size is 10. So this sample CSV file is only 10 records. And this would allow us to kind of do faster iterative development and also not worry about hitting external services. Again, this is a simple example of just using a CSV file, but I hope that you can kind of imagine how you would maybe mock services as well and like using JSON files instead of calling out to an API if you wanted to. Cool. So what I'm going to do, I'm actually going to change this .env file to point to our staging environment. And this is to emulate what it would be like to deploy to QA. So I'm going to go ahead and save that. And then I'm going to restart our Dagster service. All right, we're running again. I'm going to go here. I don't know if I have to actually reload this, but I will just to be safe. And I'm going to go back to our global asset lineage. And I'm going to materialize this again. and let me open up the code side by side. So this time, our environment is staging. So we would expect to actually call out to the City of New York's website when we materialize this. So I'm going to go ahead and click the Launchpad again. And here you can see, yeah, the location is actually the rows.csv file that's hosted here on this web server. I'm going to go ahead and materialize that. And now you can see the estimated size is 16,000 records. So still not a really big data set. But for demonstration purposes, that's how you would use different environment variables within your asset and resource. Awesome. I'm actually going to go back to this global asset lineage, and I'm going to materialize the report as well, just so we can take a look at it. I'm just going to go ahead and click materialize selected. We're not going to bother with the launchpad this time. We'll just use the default configuration. I'm going to go to the run so we can check it out. And you can see we're also returning some metadata for our report. I'm going to go down to that code here. Maybe we'll walk through it briefly. So here we're just writing a simple query to get the average value, the annual average value for different neighborhoods within New York. And we're just creating a table from that. We're replacing the whole thing. It's not incremental with partitions or anything like that. We're returning some metadata, but something really cool here is we're returning some markdown metadata from our data frame. So we'll actually have a preview of the report that's being generated. So similar to the other one, we see like our column count, the destination table, and the rows. But we also have this preview where we can show the markdown. And this was just this code here, where we're taking the top 5 rows and calling toMarkdown on it and passing that in as a metadata value.md for markdown. We can see that Midtown Manhattan has a mean of 34 parts per billion of nitrogen dioxide. That does not seem healthy, but I am not a scientist, so I don't know. Cool. Now let's talk about schedules. So we just showed how to tweak things for environments, but now let's actually show how we would use those different configurations from the schedules themselves. I'm going to go ahead and open up schedules.py here, and you can see we have our 2 schedules. One that just doesn't take in a run configuration. It uses the defaults. And then the other that in this demonstration, we're just increasing it to show the top 1,000 instead of the top 100, I think is what we had before. I'm going to go ahead and turn these both on, and I'm going to go to our daily job. So this is the one where we're overriding the run configuration. In the code, you can see in the run configuration, we're specifying a dictionary of configurations for ops. This might seem confusing at first, but assets are actually a subclass of ops. So in this case, we're defining our asset here, but it's really just an op. And we're saying we want this specific run config for our report asset. Hope that makes sense. And then I'm going to go to our daily job. I'm going to actually emulate running this by testing the schedule instead of waiting until 12 a.m. UTC. And I'm going to go here and just choose a date in the future and click Evaluate and click Open in Launchpad. Here you can see the configuration that's going to be passed, the run configuration that's going to be passed to this job. And you can see that our tweaks are visible. So instead of writing to just the New York annual average report table, we're writing to this one that has this 1,000 appended to it. And we're specifying a limit of 1,000. Again, I want to reiterate that this is just like maybe not the most valuable way to tweak parameters, but if you're doing this in production, you can really tweak things a lot. Like you can configure really anything in your Python code. So I'm going to go ahead and launch this run. And we're going to watch the logs as this job runs and our 2 assets are materialized. So you can see it just materialized our base table. And it had that same 16,000 rows. That's because we didn't tweak how that's configured. We still have our staging environment variable set to actually call out to the data.gov website. And then you can see we have our downstream report that was actually written to this /_1000 table. And we can preview that markdown Again, if you recall in our markdown, we just took the head of 5, so it's still going to be very similar. But you can see that it's now using the run configuration. Cool. So that was run configurations and using them within schedule definitions. For one last demonstration, I wanted to show how we can use the Launchpad to perform an ad hoc request. I'm going to go ahead and just open this assets.py file so we have it for reference, and we can look at our default report configuration. But I'm going to go over to our global asset lineage, and we're going to change how the report runs right now. We're going to tweak this report config. You can see right now we're looking at nitrogen dioxide. I'm actually going to change that to look at the fine particle counts. I think you could imagine a scenario where a stakeholder comes to you and says, oh, yeah, this report's great, but can we look at this instead? And instead of opening up your Snowflake IDE or working with code locally, if you wrote your code in such a way that it's parameterized, you could just go in through Dagster and leverage the Launchpad to then generate that report for your stakeholder. So I'm going to go to this report. I'm going to, oops, sorry. I'm going to open the Launchpad. And instead of looking at nitrogen dioxide, we're actually going to look at fine particles. So I'm going to come in here and just change that. And instead of writing to this destination table so that we don't overwrite our actual report, I'm going to say fine particles. I'm going to go ahead and click materialize, and we'll see what we get. Awesome. So let's look at the markdown. And here you can see now we're looking at the fine particle measurement type. And we can see there's a mean value of 12 for Midtown. So it looks like Midtown Manhattan is still at top of the list. I guess you should avoid Midtown. And cool. Yeah, so that's all I got for the demo. I'm going to go ahead and go back to the slides really quick. Cool. So that was an overview of how you use resources and configurations within Dagster. Here are some follow-ups. So you're welcome to join us on Slack. If you have any questions or feedback, we're totally open for it. If you want to try out Dagster, you can sign up for Dagster Cloud. This is a really easy way to stand up an instance of Dagster just for testing things out. It's really slick. We have a newsletter that you can subscribe to. And you're also welcome to star our GitHub repo. I know it's kind of a silly metric, but we're approaching 10,000 stars, which is pretty exciting. Maybe the 10,000th star will get some kind of swag. I don't know. There were two things I didn't talk about in this slide deck that are actually pretty relevant and interesting, just for the sake of time. And one of those is unit testing your assets and resources. I mentioned Dagster allows you to become confident in your code base before you deploy that to production. And a huge part of that is writing unit tests for your assets and resources. And because it's just Python code, Dagster is so Pythonic, it's actually really easy to write tests for it as well. So in our DevRel example projects repo, I included this test resources and configurations file for you to check out. Another thing that people have expressed interest in is using DuckDB locally and then Snowflake in staging and production. And I did include a demonstration of that in this repo as well, though I don't know if I can entirely recommend it just yet, as it's a little bit fragile. While DuckDB and Snowflake offer a lot of the same features in their subset, there are some things that DuckDB can do or Snowflake can do that the other can't. So you'd have to write a lot of like is instance DuckDB or is instance Snowflake to get the code to be really robust. But it is totally possible to do, and it would work if you used a subset of the features, but I don't think it was ready for full demonstration purposes. But that code is there, and you're welcome to check it out. Awesome. And that's all I have for you. So I'm going to open up for questions.
All right, thank you, Colton. So if there's any questions, feel free to drop them in the chat, or you can also unmute yourself and just ask a question here.
So just quick question, Stefan Barabassi from IBM. Was this call recorded? Can we re-listen the recording?
Yep.
Yeah, the call is recorded, and we'll share it as a YouTube link Probably by email, you'll get a response with the link once it's ready.
Thank you. And do you have a feature mapping compared to Airflow? Like what are the new features, how we can align it with other pipelines like machine learning pipelines? So what are the, so we, one is, it would be nice to have equivalent features to Airflow and then beyond.
We have something like that. I'll share it in the link in the chat. I'll go find it for us. There's a blog post around that.
Thank you.
Cool. Alex, it looks like you have a question.
Hi there. Yeah, my question was around like, do you have good patterns, suggestion of patterns for, I saw in the code where you're switching between two different CSVs. It's actually like quite hard to find that in the code. It's like be good to be able to sort of pull that out into configuration files. Do you have a suggested pattern for that?
So you're talking about how we were using the different environment variables to point to different CSVs, and then we have a dictionary that kind of has that mapping.
Yeah, exactly.
Yeah, I actually think, so if you go to our Dagster open platform repo, we also share how we're doing things internally at Dagster. And that pattern of using a dictionary with different environments is actually something we've done in the past as well. It seems like we're conforming on that as a little bit of a standard way of defining environment-specific resources. So that's kind of, I would recommend checking that out. But yeah, I think there are a lot of different ways to do things in Dagster, which kind of makes it a little bit tricky. But in our documentation and in the Dagster open platform, we kind of have what we consider some of our best practices.
Is that the thing you just shared there?
Yeah, I just shared that Dagster open platform link.
Because it does. I guess
actually...
if you have lots of dictionaries like that, it's like how do you? I'll check the documentation, but if it's you want it all in one place, really. So and ideally with environment variables and things to be able to see all your configuration in one place and not have to go through Python files.
Yeah, I agree with that. I like that suggestion. I could see having kind of like an environment mappings, like location in your code base where they are all stored, and then you just import those in your resources files so that you do have that kind of like environment mapping all in one place. But that's a really good point. I like that idea.
Where's the best place? I mean, it'd be good to go into a bit more detail. Like, so we have specific, we use Dagster and we have a specific use case and we have solved it using YAML files, but it's custom codes, and it'd be good to get people's thoughts on that, but probably not on this call. But yeah, where would be a good place to raise that as a GitHub issue? Or
yeah, you're totally welcome to open a GitHub discussion or chat with us on the Slack.
Okay, yeah, I'll try that.
I think a discussion is probably a good place to start because we are thinking about configuration and YAML workflows as well, more broadly. So it is something we've thought about. A discussion would be super helpful for us just to get your thoughts.
Okay, yeah, we can
Definitely.
we've done. Yeah.
Yeah, and for context, that is a common pattern to define like YAML configuration files as a DSL on top of Dagster. And yeah, we're still working on documenting best practices around that.
I got another question here, Colton from Alejandro. Have you found yourself any shortcomings when working with config or resources?
Not yet. I'm sure there may be. Runtime configurations can be a little bit tricky if you want to like pass in different configurations to the assets. But so far, it seems like the Dagster APIs support every way that I want to use the configurations. But I would suggest maybe looking at the issues or GitHub discussions to see what other people may run into. They may run into corner cases that I haven't encountered just yet.
And are there any differences in configuring resources versus IO managers? I think I can take that one on. I don't know if you've used IO managers yet, Colton.
Yeah,
but,
not too much, no.
IO managers are configurable as well, but I think they also make a lot of decisions for you. So it really depends on whether you not need flexibility. If you want the standard behavior the IO manager does and you're fine with it, an IO manager can work well. But typically we'd recommend people just use resources because they're a bit more flexible. So you're likely not to get blocked at some point in the future if you want to change, particular implementation, but both work well. There's also a question here about metadata and supporting polars. I can take this one too. You can put any type of metadata in there. That's one of the metadata types. So I think there's markdown, numbers, strings, all that stuff. So it supports polars as well. It supports pandas. All you have to do is define how to take that information out of polars or pandas. So you could do a head and then convert that to markdown. You could get summary statistics from polars and then submit those as metadata as well. Okay, so I guess the question is it a good practice to have custom configurable resources, or should resources have methods related to the way they connect to the resource only? I think I can answer this one too. I think it's up to you, right? There's nothing wrong with having custom methods in these resources if they're used more broadly. A lot of people I know use factory pattern as well in order to build these things. So I think both are fine. I would say it really depends on your use case and your users and what they want. Jason asks if it's better to use envar or if it's better to use environment variables through a config schema when the pipeline is meant to be deployed in a container. I actually don't know what config schema in a context do, so I can't answer that. I would say, oh, thank you, Yuhan, answering the question. Yeah, read that link. In short, I think envar is preferred, but there are times where envar doesn't work, and you might have to fall back to getenv. Here's a good one. Assuming you want to run a pipeline with 4 different measure types, would you recommend using config or partitions? Probably neither. I would just run all 4 in the asset, but it depends. You could use the partitions if every asset downstream is using measure type. If it's the same measure types every single time, then it might be just convenient to just have it run all 4. I think it'll really depend on your use case. Peter, I'm not sure if you're still here, if you want to ask that question or give us more details.
Yeah, sure. Can you hear me?
Yep.
Yeah, so assuming, for example, like in this case, you have a pipeline that is kind of pulling indicators from an external API. And in this case, you can pull, for example, like economic statistics or maybe like labor statistics and things like that. But then the process of pre-processing that data is kind of almost the same. Like, would you recommend setting the indicator either in the config file or like having or defining partitions that can for different indicators?
Are all the downstream assets using these indicators?
Yeah. Yeah, so basically like the step is the same. Basically, I can pull the data from the external API, pre-process that data, and then maybe can ingest that data into a database.
And are you doing all 4 measures every single time? Or do you want to like decide when to run one versus another?
Yeah, that's a good point. Yeah, some of them have more of like you wanna kind of run them weekly and others monthly.
I'd probably go config in that case.
Config.
Yeah. And then you can just have that on your schedule, right? And then the daily schedule does measure A and the weekly schedule does measure A, B, C, D, or something like that.
Correct. Yeah, thank you so much. Yeah.